Okay, so 3.1c, we're going to look at some graphs. And so overall, what we've been talking about is the derivative, right? And we've been talking about the fact that you can find a formula called the derivative that'll give you the slope of the curve at any point. And so then that is a function by itself. So there's the original function, and then there's this other function called the derivative. And they're two different functions. The first one outputs the y values, and the second one outputs the slopes. So you have to think, but you can think of them both as separate functions, even though they're connected, because the slopes of this one, or the values of this one, tell you the slopes of this one. But they're also two different functions. Okay, so we're going to talk about that some today. So for example 1, I'm just going to draw a graph that I'm calling f of x. And let's see here, get some points here. So I want this highest point here to be at 3. And I want this lowest point here to be at 5. And I want this lowest point here to be at -2. The y value is not important. So just those are the x values. Okay, so I'm going to ask a few questions about this graph. The first one is, where is f prime the largest? Where is f prime the largest? Okay, so what is f prime? Yeah. It's the slope of this graph, right? So if I want to know where f prime is the largest, then I'm asking where is the slope of this graph the largest? So where does it appear like it has a really steep graph? Yeah.
Well, I just got a question.
Yeah, sure.
Are you limited to the 3 points, or can you say between?
There are lots of points. I just didn't emphasize all of them, right? So yeah, Colin's pointing out that this is a point, and that's a point, and that's a point, right? That's what a connection is on the graph. It's lots and lots of points. So you are not just limited to the ones that I emphasized. Good. So the question again is, where is the f prime the largest? So where's the largest slope? So where does this graph look really steep? Yeah. Yeah, like right in here, it looks pretty darn steep in there, right? So that, if I was skiing, that's where it would be the fastest, right? So we're going to say at x equals 1. So where is f prime the largest is just saying where does this graph have the steepest slope? Okay, now I'm going to say where is f prime of x negative? So that means over here, what am I looking for if I'm looking for an f prime that's negative? Yeah. The graph needs to be going down, right? If the slope is negative, that means that this graph is going down. So it's going down at a lot of places, right? Everywhere in between 3 and 5. So we're going to say on the interval 3, 5. So in other words, at 3.1, the slope is negative. At 3.2, the slope is negative. At 3.34, it's negative. At pi, it's negative, et cetera, right? At all of those points in between 3 and 5. Okay, and then also from negative infinity to negative 2, right? And then you can put the U symbol in saying union of those. So I'm saying on this interval the slope is negative, and also on that interval the slope is negative. Okay, so now I want to know where is f prime 0. So looking back over here, where's the slope 0? Yeah, awesome. Yeah, these 3 points that I emphasized are, yeah, at negative 2. So at the bottom of the trough, the slope is negative. So the tangent line would look like that at negative 2, and the tangent line would look like that at 3, and the tangent line would look like that at 5. So the slope is negative at x equals negative 2, x equals 3, and x equals 5. Okay, so now we're going to take this information and we're going to draw a graph for f prime. So I opened up by saying we're going to think of f prime as a separate function. So now that we've thought about some of the things that happen with f prime, now for part D, we're going to draw a graph for f prime of x. Okay, so what I like to start with is the zeros. So over here, we saw that the slope of this graph was 0 at negative 2. So that means on the f prime graph, the value should be 0 at negative 2. Since the slope here is 0, over here, the value should be 0. So that tells us that we need to include the point negative 2, 0. And then also, the slope over here was 0 at 3. So that means the value over here needs to be 0 at 3. And the slope was 0 at 5. So the value needs to be 0 at 5. Okay, so what is a little bit tricky about this is the heights over here are the slopes over there. So this graph has a height of 0 at 5. So that means that that graph needs to have a slope of 0 at 5. Okay, then in between negative 2 and 3, this slope is always positive. So that means over here, the graph needs to be above the x-axis. Because if the slopes over there are positive, the values over here need to be positive. And positive values mean above the x-axis. So I just need to graph in between negative 2 and 3. It's going to be above the x-axis somewhere. I don't know exactly what it's going to look like yet, but I know it needs to be up here. Because those slopes are positive. So these values need to be positive. I also know that my steepest slope was right here at 1. So that means my biggest value over there needs to be at 1. I'm not sure what it is, but I'm just going to draw the tangent line in there. It looks like to me maybe this is going up 4 over 1. This is not an exact science. So I'm going to say at 1, the slope is 4. And that's the steepest slope, right? Over there. So it needs to be the biggest value over here. So that's going to be the highest point on this f prime graph. Because the biggest slope over there is the highest point over here. Okay, so I'll just connect it like this then, because I know that's the highest point. And then that just reiterates that since all of these heights are positive, since all of these points are above the x-axis, that corresponds to all of those slopes being positive. So the thing that bothers people is they really don't like this section of the graph, right? Because they feel like that's a negative slope. But what you need to think about is that this is a positive y value that corresponds to the positive slope over there, right? Because the heights here go with the slopes there. Okay. So that's all above the x-axis because those are positive slopes. And then from negative infinity to negative 2, it needs to be a negative slope. So the graph is going to be below the x-axis because a negative height corresponds to a negative slope. And same thing down here, a negative height corresponds to a negative slope. Except we got to get back to this 0, right? So it stays below the x-axis like that. And apparently then, there's a pretty steep negative slope at 4, right? So let's see if that happens. At 4, yeah, it's the steepest negative that it gets. So it's sort of negative, a little bit negative, a lot negative, a fair amount negative, less negative. That's what's going on with the slope there. Just a little bit negative, more negative. Just a little bit negative, more negative. A lot negative. And then less negative. Less negative, 0. Is everybody processing that okay? Okay, so the other thing that really bothers people is they want to get exact points over here. So I really probably should have said sketch a graph, because then that lets people off the hook. As far as, you don't need to have the exact right points over here. Now, I think the zeros should be accurate, because you can tell exactly where the zero slopes are. But as far as whether this should be 4 or 3, I'm not sure. I just knew that that was the highest point. And whether this should be negative 2 or negative 1, I'm not sure. I just knew it was the most negative in that interval. Okay, so that's sketching a graph for f prime. So now we have a picture of f and a picture of f prime. And so they're two separate functions. So that's what we're trying to get into today, is thinking of those two separate functions. They are connected because the heights over here model the slopes over there, but they are also two different graphs and two different functions. Okay. All right, so let's try another one. Here's example 2. And here's another f of x. So this is f of x, and we're going to sketch f prime of x. All right, so I'm just going to mirror that down here. That's not a very good job at all. I didn't get the y-axis in the right place. Okay, so this graph up here, I always like to start with the zero slopes. That's the easiest thing for me. So on this graph, where is the slope 0? At the peak, right? Right up here. Is that what you said, Austin, or were you saying something else?
Well, I thought specific number and then just a
Oh, sure. So you were saying,
number. And 5.
yeah, maybe 5, sure. So just make, let's just down here, the slope is 0, so down here the value needs to be 0. Up here, that's where the slope is 0, so it corresponds to a 0 slope down there. You good? You sure? The thing that bothers people is you got to switch between slopes and values. So what the y value is down here corresponds to what the slope is up there. Okay, so how about here? Comment about the slope there. It's negative, and is it really negative or just a little bit negative? It's really negative, right? Because you'd be going down fast. Okay, so it's really negative, so that means down here it needs to be pretty negative, a fairly negative value. So the -5 slope here, or whatever it is, corresponds to a height here of -5. Okay, and then how about here? Is it less negative or more negative in its slope there? Less negative, right? So that means my value down here needs to be less than it was down here, but still negative. Okay, and then here it's also less negative. And then here it's even less negative. And then it becomes less and less and less negative, right? It's flattening out towards 0. The slope is flattening out towards 0. I mean, the graph is flattening out towards 0, but also the slope is flattening out towards 0. But it's coming from the negative side, right? Because the slope is negative, 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 negative. Okay, so I guess I got this or something like this. Okay, then on the other side, comment on the slope there. It's pretty steep and positive. So that means my value down here needs to be a positive value and pretty big. So again, it's not an exact science, so let's say it's about 7. The height of 7 here corresponds to the slope of 7 there. Okay, but then this is less positive, right? So that's less positive. And this is less positive. And then as you go this way, it becomes less and less positive in its slope. So it becomes less and less positive. A little bit positive, less positive in its value. And then, I'm not sure how this connects. We're just making a sketch. But that's kind of what it looks like. Okay. Is everybody feeling okay? My sense is you're getting it pretty well, but if you asked a question, it might help me nail it home. Or maybe you don't have a question now, you'll have one later. That's okay. Okay, now we're going to switch and go the other direction. So I'm going to give you a graph of f prime now. So this is different, because in the first two I gave you f, and your job was to sketch f prime. Now I'm going to give you f prime, and we're going to try to sketch the original f. Okay, so first of all, where is the slope 0? Is the slope 0 here? No, because this is, the slope is like -1 there. The slope, I'm talking about the slope of f, right? So the value on the f prime is 0 there. That means the slope on the f needs to be 0 in that same location. So I'm not quite sure how it's going to look, but I know that the graph needs to be flat. So let's say that that's 2. So at 2, I know the graph needs to be flat. So I'll just put a little mark to make it look flat for now. And I don't know where it is. It could be flat there or flat down here. Who knows? I just know that it's going to be a peak or a valley there. Okay, then another place where the slope is 0 is here. So I'll just make a flat mark there. And also the slope is going to be 0 there. So now I've just got 3 locations where I've got to make sure my graph flattens out, where this graph is going to have a slope of 0. Okay, now for all of these points, is the slope positive or negative? I'm talking about the slope on this graph. It's negative because these y values are below the x-axis, right? So these y values are negative, so that means these slopes are going to be negative. So in between 0 and 2, I need this graph to be going down because the slope is negative. So maybe it goes like this and then flattens out here. So now I've kind of made it look flat there, and I've made it look flat here. And it's going down because these are negative values. So these need to be negative slopes. Okay, then in this section, those are positive y values. And so these need to be positive slopes. So I need to have this graph go up. Let me adjust where my 2 is here so that it looks flat at 2. Okay, then all of these values are positive, right? So that means all of these slopes need to be positive. So that means the graph needs to be going up that whole time. So it's going up from left to right. I drew it from right to left, which is confusing because it made it look like I was going down. But I'm going up from left to right because those are positive values. And then here, the slope is negative. So it's going down to there. So this is the original f of x, and then this is the graph of the derivative. Yeah?
Given f prime of x, when you draw f of x, can you have it anywhere on the y-axis?
Yeah, look, because this is just talking about the shape of it, right? So it could be that this shape is way down here because it's the same shape. Exactly. So if you have an f prime graph, you don't know where to start at. So you just start somewhere and then go from there. Good. That was a really good, did you understand that question? That was a good, because he was saying, hey, could I just have done this way up here instead? Absolutely, because it would have had the same shape. And the f prime just talks about the shape. Yes?
You know on the left side of the graph where all the values are positive,
Yes, right here.
every region is said to be positive, please make the graph big.
Sure. So you're saying this is also modeling a positive slope. Is that what you're saying?
Yeah.
Okay, so the reason I didn't do just a straight line is these values are changing. So that means the slope needs to be changing. But on the straight line graph, the slope doesn't change. So I agree with you that this would model a positive slope, but it wouldn't model the fact that this is more positive than this is. So this is steeper than this is. And that's so, but again, it's a sketch, so it doesn't, but I agree with you that you could have drawn a straight line to model a positive slope. It just wouldn't have a changing slope. Good. All right, you guys are asking. Yeah, go ahead, Colin.
Like if the straight line, the f prime of x would just be like a horizontal.
Yeah. So let's say that this is a slope of 2. Well, then on the f prime graph, it would just be always at 2. Sorry, yes, that would be the f prime for this. Because the height here is always 2, modeling that the slope here is always 2. Good. All right. So for example 4, we're going to have a function inputs time and outputs the amount of money in an account. In that case, what does the derivative represent? A function inputs time and outputs money in an account. And the question is, what does the derivative represent? Okay, so to try to figure this out, I'm just going to sketch a quick graph. Not even a graph, but just I'm going to put an x and a y axis on. So what is the x-axis representing? Time, and maybe it's in days, I don't know, who knows. Could be months, days, years, whatever, but it's measuring time. And then over here, it's the amount of money you have, so in dollars, right? So the derivative is the slope. So if we were going to find the derivative, that means we would be finding a slope. So if you go up and over on this graph, the amount you go up is how much extra money you have, and the amount you go over is how many days have gone by. So then if you divide that out, it would be the number of extra dollars you have per day. So the label would be dollars per day for the derivative. And then the derivative is the instantaneous rate, right? So if you did a slope between 2 points, that would be the average rate of change. So it would be on average how many dollars per day are coming in. So for example, if you put in $2,000 in 2 days, the average would be $2,000 per day. So that would be the average rate of change. But then the instantaneous rate of change, the derivative, would be right at a particular moment how fast the money's coming in. So it wouldn't, because if you did $2,000 in 2 days, maybe it was $1,500 the first day and $500 the second day. It wouldn't have to be a consistent 1,000 per day. But the instantaneous would tell you right at that moment what was happening to the money, whether it was coming in or going out. Okay, so it's the instantaneous rate of change in the amount of money in the account. And of course, then the label on that would be dollars per day. And that's kind of strange, because when you say $10 per day at a moment, you can't do $10 per day at a moment. It just means that if the rate continued for an entire day, then you'd get $10 more in that day. Just like if you say a speed is 30 miles an hour, that doesn't mean you're going to go 30 miles in the next hour. It just means right at that moment you're going 30 miles an hour. So that's the difference between instantaneous and average. So what's the formula for average rate of change? F of B minus F of A all over B minus A, right? What's the formula for instantaneous rate of change? The limit as x approaches A of F of X minus F of A all over X minus A, right? Yeah.
So this equals there, like, you know, 10 days graph on there, if you're looking at like X, or X equals 6, or day 6, and 9, it's the same thing. Just saying how much money is in there on that day, you know?
No, it's saying how fast the money is flowing in and out at that day.
So it's like how much money you put in that day.
Not for the entire day. It says at that moment how fast it's coming in and going out. So like if the stock market's changing constantly, your account is changing constantly. And this is the rate at which it's changing right then, the instantaneous rate. We all understand it when we think about a car, 30 miles an hour. We all know that that means you're going 30 right then. But then if you take it to an account, your brain wants to say, oh, for the whole day, because you can't conceive of money, the rate at which it's happening right then. So that's why it's tough, because we all have experience with cars and an instantaneous rate, but we don't have much experience with accounts and an instantaneous rate. But that made it better, right? Okay, good. All right, we got one more to go. This is example 5. I'm glad you've been thinking about calculus, so if you haven't figured it out yet, it's totally fine, but have you been contemplating my shirt? Like why do I have this? My A is leaning, so it's an A lean. I was like, all yesterday, I was like, what am I going to do? I don't have any alien costumes. I don't have any idea how to participate in Dress Up Day tomorrow. So, as normal, I came up with something obnoxious. One year, it was the 1960s. You were supposed to dress up like somebody from the 1960s. So I put 1960s on my shirt. So there was like a 60, another 60, a 60, and then if you counted them up, there were 19 of them. So what is your shirt? And I'd say, there are 1960s on my shirt. And the person would go, what? I don't get it. What are you talking about? Anyway. Okay, sketch a continuous function f with f of 0 equaling 5. And I'm going to give you some information about f prime. F prime of x is 3 when x is less than 2, and it's negative 2 when x is bigger than 2. Okay, so this time, Colin, they told us where to start. So remember that other graph where he said, hey, I don't know where to start because all I have is information about the shape? This one is a little bit easier because it gives us an anchor point somewhere to start. So when it says f of 0 is 5, that tells us that on my graph for f, I have the point 0, 5. So that's nice, because at least I got one point to hold on to. They gave me a point that I could put on my f of x graph. Okay, so now, before 2, the slope needs to be 3. So here's 2, and before that, the slope needs to be 3. So I can just go down 3 and back 1, and up 3 and over 1. I'm not sure what's happening at 2, because it just says before 2, it's 3. So that's why I'm putting an open circle there for now. So then I just draw a straight line graph. Should be a straight line, I'm sorry, if it got a little curvy there. Yeah, that's not good at all. That's better. I think I accidentally went up 3 and over 2 the first time. Sorry about that. Okay, so see this straight line? The slope is 3 on it, right? So that means f prime is 3 here, and here, and here, and here. So the f prime is always 3. So that's what's supposed to be happening. The f prime is supposed to be 3 when you're less than 2. Okay, then when you're past 2, the slope is supposed to be negative 2. So I'm not sure where to start. So maybe I'll start here. And then it's negative 2 for a slope. I'm not exactly right yet. Just give me a second. You're thinking good, Austin. Okay, so far I'm pretty good, right? Because I've got my slope as negative 2 past 2. So all of these points have a slope of negative 2. And I've got my slope of 3 before 2. All of these points have a slope of 3. Okay, why is this not exactly right? Yeah, Michael. But apparently it's supposed to be a continuous graph, right? So I said I didn't know where to start, but really I should have started up there, right? Okay, so sorry about that if you... So you should have gone down 2 and over 1 from there. And since it's continuous, that point must be filled in, right? Okay, so this brings us, so that's the final answer to this question. That's the final answer to this question. Is everybody okay with that? Sometimes I get a little ahead of myself. Okay, so now my question is, what is f prime at 2? And f prime at 2 does not exist. And the reason it doesn't exist is because there's a sharp change in the slope there. If you come in from this side, the slope is 3. So it kind of seems like the slope there would be 3. But if you come in from this side, the slope is negative 2. So it kind of seems like the slope should be negative 2 there. So because of that, we don't really know what to call that slope. And so we say it doesn't exist. There's a sharp change. It's 3, it's 3, it's 3, and then all of a sudden it's negative 2. So because there's a sharp change in the slope doesn't exist. Now yesterday we had a slope that didn't exist, right? Part A, we've calculated the limit as x1 to 2 of f of x minus f of 2 all over x minus 2, and it came out to does not exist. That's what was going on with the graph yesterday. It was a sharp change in what the slope was. Okay, that's called a corner point. And whenever you have a corner point, in other words, a sharp change in the slope of a graph, then the slope doesn't exist. So anytime you see a corner point on the graph, you'll know, hey, the slope doesn't exist there. All right, thank you very much for listening. I really appreciate it.